So in this video, I'm quickly going to take you through how to predict what products will form in acid-base reactions, and also how do you balance these certain reaction equations. I'm going to show you a quick and easy method as to how you can balance your reaction equation. And before you look at my answers, I would like you just to pause the video and to work through it yourself and see whether you can get to the same answers. Okay, so let's start. I picked out 5 reaction equations and we're going to work through them together. So for the first reaction, we're starting with sulfuric acid and we're reacting that with sodium hydroxide. So this is a normal neutralization reaction, and therefore a double displacement will occur, but we will look into that. So remember that when you react an acid with a base, you will form a salt plus water. Bearing this in mind, you can now go and predict the product. So if you have sulfuric acid and you react that with sodium hydroxide, the products that will form, remember, double displacement, the sodium and the sulfate will go together, and you can also look at what's remaining, OH and H, which is water, right? So you have sodium sulfate, okay, but you need to remember how to write your formulas. Sodium is in group 1, sulfate has a charge of 2 minus, so when these two combine, remember that that 2 is going to now be written like that, plus water. Okay, and now you're done with your first step, but now you need to make sure that this reaction equation is balanced. And the way in which I do this is I normally draw a pencil line down and I write down all the atoms that I have on the one side. So I have hydrogen, I have sulfur, oxygen, and sodium. And then I do this on both sides. Then I literally go and count how much of each atom I have on the one side. So here I've got 2 hydrogens plus another one, so that is 3 hydrogens. I've got 1 sulfur, I've got 4 plus that one is 5 oxygen atoms, and I've got 1 sodium atom. On this side, I have 2 hydrogens, 1 sulfur, 5 oxygens, and 2 sodiums. So now you can see that this numbers on this side here is not equal to these numbers on this side here, and that's a problem. That's why we need to now go and balance that. So first of all, you can see the oxygens are okay, the sulfurs are okay, hydrogens are not, and your sodiums are not. So I'm going to just pick one to start with, and I'm going to try and balance it. So I'm going to start with my sodium. If I times this by 2, then I will get a 2 on both sides. And that's why I'm going to put a 2 here to make that a 2. And now I just need to recount everything. So now that will give me, remember that you need to times this number into every atom. So you've got 2 sodiums, you've got 2 plus 4 oxygens, which is 6, and you've got 2 plus 2 hydrogens, which makes it a 4. Now the sodiums are balanced, but now you can see everything else is not balanced. So we need to now try and fix that. So let's look at hydrogen. We have 4 hydrogens on this side, and we only have 2 on this side. So if I put a 2 over there, that 2 times 2 hydrogens will give you 4, right? And then I will have 2 oxygens plus 4 oxygens, which will give me 6. And now you can see that the numbers on this side correspond, the numbers on this side correspond to the numbers on that side. Okay, and therefore your reaction equation is now balanced. If you look at the next example, hydrochloric acid with magnesium. So you can see you have an acid, and when you react an acid with a metal, you have a salt forming plus hydrogen gas. Okay, so if I can now go and write out and predict the products, if you have hydrochloric acid, you react it with magnesium, metal. Remember to also write in your states. I haven't written it in the first reaction. This was solution. I didn't actually specify. It could have been solution or it could have been a salt. It doesn't matter. For this purposes, I'm just gonna indicate that you can indicate it in your reaction equations. Okay, so this will give you magnesium chloride. Remember, magnesium is in group 2, so your formula will look like that, plus hydrogen gas. Okay, so now that you have your reaction equation, we just now need to go and balance it. So I'm going to draw my pencil line. I've got hydrogen on this side, I've got chloride, and I've got magnesium. So that's the atoms that you have on both sides. How many hydrogens atom do I have here? I've got one of those, and only one of those. On this side, I've got 2 hydrogens, I've got 2 chlorides, and I've got 1 magnesium. So if I want to fix this, I can put a 2 in front of the HCl, and that will become a 2, that will become a 2, and then you will see that your left-hand side is equal to your right-hand side, and your reaction equation is now balanced. Okay, looking at our next reaction equation, if we have an ammonium salt with a potassium hydroxide, remember, ammonium salt with a base will give you a salt plus water plus ammonia. Okay, so let's go and write out our reaction equation. They didn't specify in this case which salt we are working with, so I'm just going to pick a ammonium salt. I'm just going to take ammonium nitrate. I'm going to react that with potassium hydroxide. And then the salt that will form, remember, double displacement reaction. So this one and this one will go together. So I form potassium nitrate plus water plus ammonia. Okay, so let's say this was a solid, this was aqueous, liquid, and that was a gas. So now we need to now go and balance this reaction equation. So you draw your pencil line. Remember, you can just erase it afterwards. So I've got a lot of atoms in here. I've got nitrogen, hydrogen, oxygen, and potassium. So I write the atoms on both sides, and then I just need to count them. So how many nitrogens do I have on this side? You can see there's 1 and there's 1, so that's 2. How many hydrogens? You have 4 here and 1 here, so that's 5. How many oxygens? 3 plus 1 is 4, and 1 potassium. On this side, how many nitrogens do you have? 1 plus that 1 is 2. You have 2 plus 3 is 5 hydrogens. How many oxygens? 3 plus 1 is 4. And how many potassiums? Only 1. So you can see that these two sides are already balanced. So your reaction equation is already balanced. Okay, looking at example 4. If you have a carbonate, you react that with an acid, then you have salt formation plus carbon dioxide plus water. So if we go and write out my reaction equation, you have calcium carbonate. Remember, calcium is in group 2. Carbonate is a polyatomic ion, always looks like that. So when you combine them, those two charges or valencies cancel in your formula, plus nitric acid, and let's say we added a salt to a solution. And so what will form is calcium nitrate. Remember that nitrate has a charge of -1, and calcium is in group 2, so that's what your formula looks like, plus carbon dioxide plus water. If you're struggling to write down the formulas, you need to make sure to practice this a lot, because if you can't write down the formulas, you won't be able to balance your reaction equation. So now you can see that there's a lot of atoms here as well. So I'm drawing my pencil line, and I'm going to write down what I have. Calcium, carbon, I've got oxygen, I've got hydrogen, and I've got nitrogen. Calcium, carbon, oxygen, hydrogen, nitrogen. So how many calciums do I have on this side? Only 1. How many carbons? Only 1. How many oxygens do I have? 3 plus 3 is 6. I've got only 1 hydrogen, and I've got only 1 nitrogen. On this side, 1 calcium, 1 carbon, 2 plus 1 is 3. And remember, whenever you see a bracket, this 2 multiplies into both atoms. So I've got 3 times 2, which is 6, plus 3 is 9. So I've got a lot of oxygens on that side. I've got 2 hydrogens, and that 2 applies to that nitrogen also. So I've got 2 nitrogens. Now, let's see how we can balance this. Let's look, for example, at the hydrogens here. You can see 2 on this side, but only 1 on that side. So to make this simpler, I'm going to place a 2 over there. So that will give me 2 hydrogens, 2 nitrogens, and 6, 2 times 3. Remember, this times in every atom. So that will give us 6 plus 3, which is 9. And now you can see both sides are balanced, and your reaction equation is therefore balanced. Okay, looking at our last example where we have magnesium carbonate and sodium hydroxide. So again, another carbonate will give you salt plus carbon dioxide plus water. So if you go and write down your balanced reaction equation, magnesium carbonate plus sodium hydroxide, and the salt that you will form is magnesium hydroxide, double displacement reaction, plus carbon dioxide plus water. Okay, so once again, depending on what the reaction told you, they weren't very specific, but then based on what they tell you, you can just put in your states: gas, liquid, and so on. And this would also then be in solution. Okay, so let's quickly balance this reaction equation. Write down your atoms on both sides. I've got magnesium here. I've got a carbon, oxygen, sodium, and hydrogen. So I do the same on this side. Carbon, oxygen, sodium, hydrogen. So how many magnesiums do I have here? Only 1. 1 carbon. I've got 4 oxygens. Remember, 3 plus 1 is 4 oxygens. I've got 1 sodium, and also just 1 hydrogen atom. On this side here, I've got 1 magnesium, 1 carbon. Let's look at the oxygens that we have. That's 2 plus 2 plus 1. So that's 4. I've got sodium and hydrogen. Now, question is, where on earth is your sodium ion? Your sodium ion can just be in solution. Sodium carbonate can form Okay, so you can see that that was not included in this reaction. So sometimes you can have various things forming. You can have magnesium hydroxide forming, and you can have sodium carbonate forming, for example, instead of carbon dioxide and water. So it really depends on your reaction. So in this case, we are going to consider these reagents forming instead of the carbon dioxide and the water. And the reason for that is because the sodium is very reactive and it's going to displace the magnesium, and we're going to talk about displacement reactions. So that's going to then give us sodium carbonate. Okay, so if I can just quickly finish up balancing this reaction equation, and now you can also see that your numbers will change. So let's just maybe try that again. Just put my magnesium back here. So let me just try that again. So magnesiums, we have 1. Carbon, we have 1 of those. Oxygen, there's 2 plus 3, which is 5. We have 2 sodiums and we have 2 hydrogens. So if we can quickly try and balance this, you can see hydrogens are 2 on this side, only 1 on this side. So if I put a 2 there, then I will get 2 sodiums on this side. I will get 2 plus 3, which is 5 oxygens on this side, and I will get 2 hydrogens. And as easy as that, you can see then that both reaction equations are balanced. Okay, so be careful when you analyze the products that will form. You can see if you compare this reaction to the one above, where we had hydrogen. In this reaction, we worked with sodium, so there was another metal involved, and that's why instead of forming a salt plus carbon dioxide and water, we will form 2 salts, okay, based on a double displacement reaction. Okay, thank you guys. In the next video, I'm going to talk about salts and oxides, the different types of oxides, and then also precipitation reactions.